Hi everyone, this is Dikshit. Welcome to my channel. In this particular video, we will going to discuss about daily activities of a cloud or a DevOps engineer. And this is not the first video. I've already made a couple of videos on daily activities of a cloud or a DevOps engineer. If you have not watched them, please do watch it. I'm going to provide the link in video's description. And also one disclaimer. So whatever the task that I'm going to discuss, it's not that you'll also get the same tasks. It really depends on project to project, organization to organization, and client to client as well. And this video will definitely help somebody who is searching opportunities in DevOps area and also have already started working on DevOps projects as well. So now without wasting any time, let's get started. The first task that I want to discuss is automating manual tasks by using Python scripts. In DevOps, it's not about always using tools like Jenkins, Docker, Kubernetes, Ansible. So sometimes you're going to come across the tasks or activities where you can't use these tools. So that's where scripting plays a very, very important role. So in my case, I've mostly used Python or shell scripting. So few of the activities where I've used a Python scripting, I'm going to discuss about that. And also guys, like in nowadays, I can see in DevOps interviews especially, scripting is a mandatory skill. If you don't know any scripting, so then I would strongly suggest you to read about or at least learn the basics of any scripting languages. It can be Python or shell scripting as well. The first task is rotation of tokens and SSH keys, which were there in AWS secrets. So before explaining like what Python script was doing, so let me explain the background for why we wanted to do this. So we were using Jenkins as a CI/CD tool in one of the project. So when I say CI/CD, so we will be writing a lot of pipelines, and in pipelines we will have stages like clone, Artifactory download, push to Artifactory, authenticating to Kubernetes cluster, deploying to servers. It can be many steps will be there. And in most of the steps, so we depend on some external tools like it can be Artifactory, Docker Hub, or it can be Kubernetes cluster, SCM. So many tools will be there. So if you want to do any activity with some other external tools, so then you need to authenticate. If you want to authenticate, then you need to store these tokens, SSH keys, username, password somewhere. So in Jenkins, they provide an option which is called as credential. In this credential, you can store username, passwords, tokens, and SSH keys. But in traditional Jenkins credentials, we have a few issues. One is versioning was not there. So versioning as in, let's assume a new token is updated to some credential. And if that new token is failing, so due to some issues like that token has lost some access and it is not working properly, I want to roll it back to the previous value. And in traditional Jenkins credential, it is not possible. So that was one problem. The other one is, let's say if some credential is there and somebody deleted it, accidentally somebody deleted it. In that case, how can we get that credential back? Is it possible? The answer is no, you can't get it back. You need to create it manually again and then you need to use it in pipeline. To avoid these particular problems, what we did is we had installed a plugin which is called as AWS Secret Manager. So when we install that particular plugin, so Jenkins will get a capability to read the data or like secrets or credentials from AWS Secret Manager, which is a service which is then the AWS. And when we used this particular methodology, we got few advantages. One was versioning was there. If somebody updates the value and can I get back the previous value, the answer is yes. And if somebody deletes, can I recreate it? In AWS secrets, we had a rule where if the secret is deleted within 30 days, we can get it back as well. So that's where that advantage is also there. And to read and update values, it's easier. Like we can view what exactly the value is now. That is also one of the advantages. And it was really going well, but our organization or that particular client came up with a rule saying that for every 6 months, we need to update the tokens or SSH keys due to some security concerns. And for a few days, we started it doing manually, but sometimes the developers or like engineers who were assigned to that particular task were like delayed that particular activity, due to which a lot of pipelines started failing. Because after 6 months, those tokens or SSH keys will be expired and pipelines started failing. And then again, we will going to prioritize that particular updation of the secrets task, and we used to do it. And we wanted to kind of avoid this particular situation. So that's where we wanted to kind of rotate these tokens or SSH keys automatically without any human intervention. So that's where we came up with an idea. In AWS Secrets, we have an option where we can trigger a Lambda function periodically, so that it can be like every 10 days or every 90 days if you want to trigger that. That is possible in AWS Secrets. So we use this particular option. So periodically for every 90 days, we used to trigger this Lambda function. In this Lambda function, we had written a Python script with a combination of Boto3 library, where what it does is it will going to read the existing value of the secret, and depending on the tool or like token which is there in that particular secret, we wrote a Python script in such a way that it will be able to identify the tool and type of a secret, and then it will gonna create a new secret and it will gonna update it back to this particular secret. Before updating back, it will gonna execute some test, and if that test successful, then only it will gonna update it. If this test fails, then whatever the previous value is there, it will be with that only, and it will be retried. This particular rotation will be retried after some time. So that was the mechanism that we have used, due to which the manual intervention we have completely removed, and this rotation was kind of happening properly, so that even like the pipeline failures, we could able to avoid it. So this was the one task where I used a Python scripting, and where we have automated rotation of SSH keys and token rotations. And the next one is GitLab pipeline status. In other project where I was using GitLab CI/CD for pipelines, and where we were triggering a lot of pipelines, daily pipelines, and commit pipelines, MR pipelines, so many pipelines we were kind of running it there. But our management were wanted how many pipelines on a daily basis that we are running, how many are successful, how many are failure. They wanted that particular metrics. But unfortunately in GitLab, we don't have that particular dashboard where we can visualize all this particular data. So that's where we wanted to kind of store this particular data somewhere, and then use it in our visualization tool, which is Grafana. So that's where we implemented a Python script. So in this Python script, by using GitLab APIs, we're gonna read the pipeline information. This Python script will gonna run in the last stage of all the pipelines, where what it does is it queries the information about previous stages, whether it is successful, failure, how much time it took, all that information it will gonna collect, and then the Python script is also responsible for inserting that particular data into Postgres database. And once it is inserted, from there we used to read it onto our dashboards, like which was like created in Grafana, and we used to read it. And this was really helpful because by using this particular data, we could also uh, judge a lot of things: how much load will be there, how many pipelines will be running on a given certain days. All those metrics were captured, and it was really helpful as well. So this is where we had used the Python script to get the data from GitLab and insert it into the Postgres team. And the next one is Artifactory upload. So as you can read on the screen, so you might think of it is easy, but why do we need Python scripting here? So in our case, whatever the builds that we were launching, it used to create a lot of files. And all those files, we don't wanted to kind of upload it to Artifactory, because which were not necessary. So that's where we wanted to kind of filter and upload whatever the filtered files we get, right? So we wanted to upload it to JFrog Artifactory. And this filtration was also depending on the pipeline, depending on the team, or like depending on the pipeline type. So we wanted to kind of filter it. So that's where we had used a Python script where we take the input, the list of files, and depending on the pipeline and depending on the teams from which it has been triggered. So we're going to filter the files, and then we will upload it that particular into JFrog Artifactory. Because if we upload everything, so then it's a pressure on JFrog, as well as which is not used by anyone. So it doesn't make any sense. So that's where we had used this Python script, filtered, and then we used to upload it back to this JFrog Artifactory. And also the location of the Artifactory also used to vary. That is also very important, that we used to construct it in this particular Python script itself. And the next one is tool check. So before explaining what that Python script does is like we had a pipelines. where we had stages very similar to this. One is cloning, downloading, building the project inside the Docker container, unit test cases, code coverage, feedback to the user. These are like common stages that we had. But one problem was like sometimes what used to happen is as our pipeline depends on multiple external tools like Artifactory, SonarQube, SCMs. So when we executing this particular step, then the SonarQube used to go down and it was maintained by other teams. And though we have executed the build, and user will be waiting for his feedback, but SonarQube is down. So which was causing a lot of issues because we have already executed some steps and our infrastructure has been used and which is associated with some cost. And due to the SonarQube downtime, again we need to rerun. And also the productivity of developer was also kind of impacted. So that's why to avoid these particular problems, to avoid the infrastructure cost, if some certain tool is down, are like to improve the developer productivity. So we came up with an idea that in the pipeline start itself, we'll have a stage where we do a tool check. Whatever the external dependent tools that we are using in the pipeline, we kind of list down them and we execute a health check on these particular. If the health check is fine, so then we will move ahead. If health check is not proper, then we can give a early feedback to the developer so that even he is aware of it. And also our infra cost will be reduced. So this is where we implemented a Python script where it will gonna read the list, where it will have SonarQube details, URL, Artifactory URL, and Kubernetes information, everything it will have. It will gonna execute a health check on each and everything. And if it is successful, then only it used to go for two further stages. So by which we could avoid a lot of issues like where it used to fail in the middle because of some downtime of some external tool. And then the next one was AWS billing notifications to MS Teams. So in many of the projects I've seen like this is a very common thing. So we'll have some common MS Teams channel where we will get a lot of notification about different information about the project. So in our case also where we were using AWS cloud for our infrastructure, and unfortunately, the whole team didn't had access to the billing information. But we wanted to kind of keep it that particular billing information to the whole team so that if it is more, then team can take some actions to reduce it. So that's where we had written a Python script. So what it does is it'll have a rule attached wherever it runs, right? That particular machine or like Lambda function will have a role in such a way that it can access that cost information, and it will gonna read the Python script will gonna read the information from AWS Cost Explorer, and it will gonna do some calculations, and then it used to send it to MS Teams. So that the entire team will gonna look these particular statistics are the cost, and if they want to take some kind of activities or like actions on that, they used to take it to reduce that particular cost. So this is also one of the Python script where I've worked on. And the next task is MR or a PR review, a merge request or a pull request review. And this is, I would say, one of the most underrated tasks. So in whatever the projects that I've worked on till now, so fortunately, where others work, I got to review it. So this is a very important whenever you join for any project. It can be a development project or a DevOps project. If you review others' work, definitely you're gonna get their ideas as well. As someone doing your colleagues are, if they're doing some kind of um, wrong changes, then you can suggest them. You can see different perspective of each and every individual. It's not about only reviewing their work. So whatever the changes that you make, so you should send it to your colleagues so that they can review it and they can give their perspective as well. So that if you do this particular activities, right? So then you're gonna think about different types or like ways we can achieve the same activity, and whichever is better, we can take that particular one. And so this is also very important. And I had done a lot of merge request reviews and pull request reviews. And this is, as I said, one of the most underrated tasks as well. But eventually, like we spend a lot of time in these activities as well, because any work which is going to the production, it should be very proper. It's not like only one person idea and it has went to production. It should be now to whole team and then it has to move to production. Next task that I want to discuss is migration of pipelines from Jenkins to GitLab. So for one of the client where we were using Jenkins as a CI/CD tool, and the management has decided to move towards GitLab. So due to many reasons, one of them was there were multiple projects which were running in that particular client, where few were using already GitLab CI/CD, and so that's where they wanted to use one common CI/CD tool. So that's where whoever was using Jenkins, we wanted to kind of migrate it to GitLab. And as well as already in that particular client, we were using GitLab for SCM, and already GitLab offers CI/CD tool. So that's where why not we use that particular features rather than depending on one other external tool. And every time, so we used to upgrade it because whoever was using Jenkins, right? So they need to manage the upgrades, downgrades, security concerns, everything that we used to handle it. So we wanted to kind of avoid that as well, because that is a repeated work or a infra support activity that we need to do it regularly. If you go for GitLab, so then so one there will be a centralized team, they will gonna manage it, and all other project related CI/CD teams they should write are like concentrating on only pipelines. So that was the main reason we migrated from Jenkins to GitLab. And it was not easy because in Jenkins we have different concepts and the way GitLab works is totally different. The fifth activities where I was involved in GitLab runners. So in Jenkins, we have something called as master node, and from there it can launch the slave nodes, and upon that slave nodes, we can run our jobs. Or if you want to run it on master also, that's fine. But usually in production grade Jenkins, they create a new nodes, which is slave nodes, and on top of that, we execute the jobs. But in GitLab, which is very similar to agent, here we have something called as GitLab runners. I was part of installing and configuring this particular GitLab runners. So when I say installing and configuring, so it's nothing but we'll have one machine where we need to install GitLab runner. And then once it is installed, we need to provide a configuration. What type of a runner that you're going to use, either Docker, Linux, or a fleeting, and there is Docker plus runners are there. I don't want to kind of explain each and every runner type here, but I was part of installing and configuring GitLab runners. And the next very important thing was in Jenkins, we used to use Groovy scripting, scripted pipelines, and declarative pipelines to create our pipelines. But when it comes to GitLab, it is about YML. So converting all those Groovy scripting to YML are like some kind of scripting, Python or a shell script. If there is a lot of logic, we can't do it simply in YML, right? So that's where we used to write the scripts, and then those scripts we used to call it in the pipeline. So as part of converting those Groovy scripts into Shell and a Python, and also upon calling on the GitLab YML as well, that one. And in Jenkins, we had option to create as many pipelines that we need. So either it can be MR based pipelines or daily pipelines. We have that particular options. In GitLab, we can't create pipelines as such, like as we require. So per repo, we can have only one GitLab.gitlab.yml. So that's where you need to define all the stages that you want to execute. But in our case, we had some pipelines that has to be run on daily, where it executes the build and upload the artifacts. And we wanted some pipelines where it runs on the MR based or commit basis, where it's gonna build and provide the feedback to the developer. So if you want to run a certain pipeline daily, so then we need to use options which is called as pipeline schedule. So we have experimented and used efficiently this particular pipeline schedules as well. And afterwards, like in the Jenkins, we have something called as artifacts. So whatever the output files which are generated in Jenkins, we can store it in Jenkins itself, and users can use it. For example, it can be a HTML report. So let's assume you have executed a test cases. Code coverage report, we can store it as an artifact, and the users can view it, and then they can take or like rework on by looking at that particular report. The same feature we wanted to implement it here because the way we wanted to kind of migrate was less impact on a developer productivity, because we don't want it to change much things. So it won't be a problem for a developer. So we had used option artifacts where we can store the files within the pipeline itself, where user can easily go and access and read if any reports are available. So those things also we kind of experimented and used in GitLab pipelines. And the next one is very important, container registry. In Jenkins, we can use Docker as agents. Here also in GitLab, we can use Docker image and container as a agent. And whatever the Docker images that we were using, in Jenkins, we used to keep it in AWS ECR. So whenever a pipeline is started, it will gonna pull the image from AWS ECR and build will be executed. But in GitLab, so rather than putting it in AWS ECR, again, which takes a bit of time to pull it. So we had used a container registry where we stored all the base images which are required. So GitLab, as it is within GitLab feature, so the pull was very faster and we could able to launch the builds as soon as possible. And also we'd use this container registry to store the output images as well. So all these options we had used, and the main work or much work gone into conversion of pipelines from Groovy to YAML, or like shell or Python scriptings as well. And this is very common in many of the clients or projects I've heard from my friends and also people who reach out to me. So they do migrations like this. One of the famous migration is from traditional VM deployments to the containerization. And nowadays, people are moving towards traditional CI/CD tools towards GitOps because they want to keep everything in one place. And apart from this, like once the migration is done, so one of the other major work is documentation as well, because the reports and the way it was executing was completely different. Developers has to be know about that, right? So we used to create a lot of documentation, and those documentation also we used to do it in inside the report. We used to use .md files are like wiki pages, and we used to write the documentation so that everything documentation pipelines and the code, everything is at the same place. That is what ultimate goal of this particular migration. And the next task is pipelines to deploy infrastructure. In one of my previous daily activities video, I have discussed about this EKS cluster, where we were using what we were doing it in this particular EKS cluster. And you can see that a lot of components were there, like a lot of node groups, EKS cluster itself, Jenkins, Gerrit, Grafana, Prometheus, EFS, S3, and there were a lot of other components were there, like network components, VPC, subnets, internet gateway, many things were there. So deploying this manually will create a lot of issues. That's where we created our pipelines. We had GitLab CI/CD pipelines where we gonna kind of read, or like developers can trigger those particular pipelines depending on whatever they want to deploy, and we will gonna read that particular code and backend file, and then we will gonna apply the configurations. And here user can choose like what he has to deploy. So it is not like whenever we run pipeline, all infrastructure will be deployed. So developer add an option where you can select if you want to deploy only Jenkins, then you can choose that particular option or provide a variable, and then you can run the pipeline so that only Jenkins will be deployed. So as part of automating this as well, to deploy the infrastructure via pipeline. And then, so moving on, the next thing is configuring and creating an alert. So in DevOps projects, it's not about always like creating a Kubernetes cluster, writing pipeline, or automating something. So whatever we do it, we should monitor also. Observability is also very, very important. So if you have automated something, whether it is working properly or not, how much time it is taking day by day, whether it is taking more time or it is reducing the time, all those things we need to definitely monitor it. So in my project, we were using a lot of tools like EKS, Amazon EKS, Kubernetes cluster. We were using GitLab CI/CD, Jenkins CI/CD, Gerrit as a SCM, GitLab as a SCM, and many other services within AWS like S3, EFS. All those metrics we wanted to capture. For example, if you want to say Amazon EKS, I want to check whether node health is proper or not, and also what is the load on each node. I want to test it. And in the GitLab, how many pipelines are running on a daily basis, how many are success or failure, and what time each pipeline is taking, each stage is taking, so that I can correct something and reduce the pipeline time. Same with like Jenkins, the pipeline statistics. And when it comes to Gerrit, how much load on a certain point of time when developer tries to clone, what is the time to clone it, and in which time of a day I have more load, all those kind of metrics. And coming to S3, what files we are storing, how much GB of data that I'm storing, whether on a daily basis it is increasing, old files I'm deleting it or not, how many files that I'm keeping, all those metrics are very, very important to observe. Only I've taken 1 or 2 points about each particular tool, but there are many other metrics that we use to capture it. So what we used to do is like we had a tools like Prometheus, InfluxDB, and Postgres. So using different mechanisms, we used to capture or pull the data from these uh, systems, and we used to capture it in this. And all these particular details, we used to fetch it over Grafana and used to create very visually good dashboards, which was used by management. And also upon that, it's not about only dashboards. If something fails, let's assume GitLab has since last 24 hours, all the pipelines are failing. So I don't need to wait for a developer to report it. If there is some issue, DevOps team or like whoever is responsible for that has to be notified. So in the Grafana itself, we used to create alerts. So whenever something is down or like something is going wrong, so then we used to get alerts so that we can take a corrective actions as soon as possible, so that developer productivity or like infrastructure cost is not wasted. So I was part of this as well, configuration of like reading the data from different systems, creating alerts, creating dashboards. So these are the activities that I'd worked on in this particular configuration and creating alerts. And that's it for this particular video. And one request. So in my YouTube analytics, I've seen only 25% of my viewers has been subscribed. So 75% still not subscribed. It would definitely encourage if you consider subscribing to my channel. It motivates me to do more and more videos like this. And please do subscribe, like, share, and share it with your friends as well. So that's it for this video. Thank you. Have a great day.